This is Kulali and her owner Garth. Garth was a successful engineer who started building Kulali as his final life project. Unfortunately, Garth never got to see her finished. I've been lucky enough to take the challenge on of completing her build and one day to sail her around the world. Similar to Garth, I'm a passionate engineer who loves to know how things work and how to build things. Join me on this journey to bring Garth's dream to life. This is Sailing Kulali.
Hello, welcome back to Kulali day 9 or 10, something like that. Today's an exciting day because we're going to use the lathe for the first time to make the first parts on Kulali. Thanks so much for watching. Stick with me, let's see what happens. This is the AL-320G lathe that I got. I've never turned anything in my life before, but I got this lathe because there's a lot of parts in Kulali that need to be turned up and it would have cost too much money to go and get someone to go and turn the parts up. So I got this lathe because I thought it'd be a cool skill to learn how to turn things, and it will also save me money in the long run. Alright, so the first part we're going to design up for the lathe is going to be the pins that go into here. So basically the pin's going to go through here, and then I think it's either going to be tack welded or a screw that goes in to retain that pin from sliding. I guess that's the idea with what these cutouts are. So this is a better view. So I'm going to make the pin go from about here to about here, I think. And I think that should be plenty. So total distance of about 100 mil seems like a nice number. So we've got a 100 mil pin and then chamfer the ends. Let's draw that up. 60 mil pin. What's the diameter of this thing? About 19 mil. Try that again. Alright, so this is the design of the pin. It looks really simple, but I'm pretty scared because I've never turned anything functional in my life. I think we'll make these maybe like 3mm chamfers. Yeah, so this is the idea. I've got some aluminium stock and let's do it. So this is the aluminium stock that I bought. It was about, I think it was like $20 for a length. I think it's 20 mil, I'll double check, but this is what we're going to be turning the parts out of. So the first step will be to use a cold cut saw to cut the aluminium the right length. So this thing sets the length that you're going to cut, and that's set to the blade right now. I've never used this before, and so we're going to mark 100 off here. Doesn't need to be amazingly accurate. Done. Alright, so this is the dowel that I cut from that rod, and I've already made a mistake. I cut that at 100 mil long, and I think the first step you actually should do is a facing operation to make this square. So I'm actually going to make the design now 95 mil instead of 100 mil. So it's cool learning, but yeah, you always cut something green, which means there's extra length, and then you cut to the right length. So I'm going to do that now, so down to 95. Make sure that's off, good. And we're going to put that in there, do a facing operation. So one thing that I learned from the YouTube videos I've already watched about turning is that when you put something in, you can either turn it as you tighten this, which is pretty hard with this noob spring on, but I'm not taking the noob spring on until I'm a little bit more experienced with this machine. So you push this, you can, instead of turning it, you can have it on the bottom tooth so that the bit doesn't, so the part that you're putting in won't drop and be off center. But it seems actually pretty easy to spin. That's it. So I bought a couple new toys for the lathe. They're only cheapy toys because like I've got to try and keep this project economical. That's a drill chuck which allows you to put a drill bit into the end of the lathe, or the quill I think it's called. That's center drill set to put centers in. We'll learn about that soon. A drill chuck for the drill, and then some cut-off blades and HSS or high-speed steel tool bits. Let's do it. So this is a parting block tool. So I'm guessing that this parting blade fits inside that parting block. Parting blade, keep things clean. So I'm presuming that's how it goes together. And you want to keep things, so the idea about lathes from what I've read is you want to keep things as rigid as possible, so the shorter that you can go the better. So I'm going to keep that around there. Stops chatter, which is what ultimately breaks tools and gives you bad surface finishes, which cheap Chinese lathes like this one probably will deliver. I guess this is how you use this, I don't know. But that seems pretty solid. There's interesting taper there. Guess that clears the chips. Cool. And that goes in here. These are some shims. That is how it goes in, right? So let's check this quickly. So the first step apparently is to check that this is in the center of the tool piece. So how you do that is you move this all the way out across to this side. Or I guess I could have moved that thing close to this side. So you can see the cutting tip is not in line with the center of the lathe. So I need to lift this whole thing up a little bit with the shims to align that with that. So I'm just going to measure that distance between the two bits. So one thing I'm struggling a little bit with, hopefully future viewers of this video will be able to help, is I can't seem to, when I screw this down, it seems to twist the whole thing, like rotates the whole thing that way. So you can see it's not square. And yes, I've tried to butt this up against there as I'm tightening it, but it seems to just push it out. So I'm not really sure what's going on there, but we'll try the cut anyways. All right, and this is how you select the speed. Apparently with aluminium around 600 or steel 600 is fine. But I want to go slower just for today. So I'm going to go to 350. So that's 350 there. And yep, 350. Cool. And this here is the power feed. So there's cross power feed and in and out power feed. No idea what the terms are, but someone will correct me. And that's just the direction of it. So I'm going to take my watch off because you apparently don't want any sort of jewelry on or anything that can get caught. Okay, here we go. First operation of the Kulali part on this lathe. So we've got that, no cross feed, nothing's there, that's off, that's disconnected. Let's go on. So this is a automatic cross-feed operation. I've never done this before. So the tool is driving itself in, so it should give you better finish results because it's smooth, like a more consistent finish. So let's just see what happens. I don't really like this so much, but and then we close that off by doing this. So once it's done, all the way through, nearly there. 3, 2, 1, pull that into neutral. Yep, that's into neutral, done. So, off. And let's see, so we move this to the right. Okay. And what's the finish like on that thing? Cool. It's still pretty rough, but it's better than my hand done one. So this is the part so far. It's 20 mil thick. It's been faced on both sides, but it's not any sort of specific length. So I need to machine that down to the right length. I'm going to measure the total length and then bring it back down to 95 as the first step, I think. Oh no. Yeah, I think that's the first step. All right, so I measured that and that was 98 millimeters and I want it to be 95. So I'm going to take 3 mil back from there. So I've butted that up to that face and now I'm going to go 3 mil on this. So set that to 0, take up any backlash, and then go 3 mil that way. I have no idea what I'm doing, so I don't think this is right, but whatever. So that's 1 millimeter, 2 millimeters, 3 millimeters. So that's in 3 millimeters now. Okay, let's go on. Hand cut this one. I reckon the belt's slipping. Alright, so that's the part that's been... took a long time to do that actually, but this should be 95 millimeters. Let's see, after a lot of work. 95 is pretty accurate. Cool. So now what I want to do is I want to turn this part down, which is 20 millimeters, down to 18 millimeters. So it's 1 millimeter in should take 20 millimeters. 1 millimeter in should take off 2 millimeters total. So let's go do that. All right. So this is my first. What do you call it? I don't know what do you call it? Whatever. We'll work it out. Let's put this in here. God. Put this in here. And then new toy. This is the new toy that I got recently. Very exciting. It's a magnetic dial indicator set. Let's open it up. Cool. So that's the magnetic base. Turn that on. Locks it in. Ooh, it's pretty solid. Okay. Okay, so that's on. Dial indicator. And so if I spin this, woo, tells you how offset it is. You know what I'm saying? So that's lower, and then this is getting higher. Lower, higher. So we give it a couple love taps this way. And then, that was actually surprising how well that worked. Tighten that up. So that's pretty concentric. So now we're going to drill a hole at the end to stabilize the whole thing. So this is the drill arbor. It's weird because they look different, don't they? Oh yeah, that seems to work. So let's see that. And this is the drill chuck. Cool. Okay. So you got a number what? You got 1 to 5. They said number 2 is good. So I'm presuming that's number 2. Slide that pretty much there. Okay. Then we're going to try and drill a hole now. 1. Maybe go a bit more. 1.25. Have a look at what that looks like. center bit's out. That is out. Getting that across in there. So the idea is that that center hole that's been drilled is going to go into this dead center. So this is not a rotating one, it's called dead center. I think it's just a cheaper version, and that just supports the this as it spins. You're meant to put some oil on it there. So now, so when I spin this up, it should stay really secure. Alright, so this is finally set up. It took like an hour. So we drilled the hole, the center bit hole, the Morse taper, the dead center is here. That holds that in place tight, nice and tight. And then we put this cutting bit on there. It's nice and secure. So let's try. Apparently that's really bad, this stringing, because it that heats up a lot, so that's bad. So there's something going on. I think it's cutting speed or whatever. I've got to adjust that. But yeah, this stringing here, that's no good. That's not a good thing, apparently, from what I've read. So I'm doing the final pass to 1mm now. So that's 1mm in. Autofeed on. And here we go. This is the final pass. I've increased the speed of the drill quite a lot. A lot of shit going everywhere. Cutting on 600 RPM now. Alright, so that's now down to 18mm it should be, because I took 1mm off. We'll just double check that real quick. Squeeze that on there. What's that? 19mm? Well, we'll double check that. So that's weird. That was definitely 1mm I took off. So it says that it's still only 18.9mm. So I need to go another another 0.9mm off. Alright, that's down to 18mm now. So that's pretty cool. So now the idea is that part of the shaft is 18mm, but that bit's not. So we're going to rotate it and square it up and then take that back down to 18 as well. Let's do it. Alright, that's it. That's the last pass that's been done. So I'm going to undo this. My noob chuck. And then that should come out. So yeah, that's the final part. I'm going to measure it up and just double check. Yeah, about 18mm. So let's go try it. I'm not going to put the chamfers on because I'm running out of time. It's nearly 5 o'clock. So yeah, I'll just clean this part up a bit and then let's do it. Let's try it out. Alright, 18mm. Ooh, nice. Let's try this. Oh no, there's something in there. Shit. Alright, so the idea is that you push it in and then you can adjust the position of it with this there. Cool, so that one's working. So there's only 1, 2, 3, 4, 5, 6, 7, 8, 9 to make, and then we're done. Alright, the battery's run out. Thanks so much for watching. That was day 10. Done on the first part of the lathe. We'll do more tomorrow. Okay, so these are the ones that I've done today. You can see all the swath there, and basically you have, that's the first one for today. The surface area finish is pretty rough. I think it's to do with not being supported that well. Then these are all just 0.5 mil cuts, and the surface finish is way better, apart from the ends, which when they're unsupported seems to have that issue of chatter again. And the last one I did a tiny little finish cut of about 0.1 millimeters as a finishing pass, but it didn't really work out that well either. So still learning, but it's looking better.